Implicit differentiation is just an application of the chain rule, man, or woman, depending. Okay, so what is the chain rule? The chain rule is used when you have a composition of functions, a function within inside a function. So it would be the derivative of the outside with the inside the same times the derivative of the inside. Okay, all right, that's fine. But what if I wanted to take the derivative of something like, let's say y cubed. That's ugly. That's ugly. So let's say we're going to take the derivative of y cubed. Well, suppose, we're taking it with respect to x, and this is y. So something's a little fishy here. But we're going to suppose that, this has to be true if we're going to do implicit differentiation. We're going to say that y is a function of x, meaning I could rewrite y as something like this, function of x. Okay, well that's fine, so let's see what happens. I don't know if you can see it now, but I have the chain rule where the outside function is the cube function, and then the inside function is f of x. So I just use the chain rule. The derivative then is 3, you keep the inside the same, f of x, squared, right, because you're using the power rule, times the derivative of the inside, f prime of x. However, f of x was y, and f prime of x, that's dy dx. And that's normally how we write it with implicit differentiation, because it's more explicit. Implicit. Okay. So what does that mean for us? Well, there's a shortcut. There's a way to think about it. This is why implicit differentiation. This is why implicit nope. This is why it works. So really what I think of is whenever the variable on the bottom for the dx or dt or ds or whatever, if this variable disagrees with this, then this is what I do. So let's say, yeah. So if these variables disagree, then the way I think about it is, well, you take the derivative like normal, pretending that, okay, it's just a regular x. So the derivative of x cubed would be 3y squared. 3x squared, but we're pretending. We're make believe, like Neverland. Neverland is real. I've seen Hook. It's not a documentary. It is a what? So you take, if those disagree, you take the derivative like normal, and then you tack on a dy dx. So it's the derivative of just y, and the derivative of just y is dy dx. So that's what I'm going to say. If those disagree, take the derivative like normal, tack on a dy dx. Then so if those variables disagree, you take the derivative like normal and tack on a dy dx. That's what I think of every time for implicit differentiation. And that's the end of this video. I'm going to go watch Hook. No, I'm not. I have work to do.